Hello there and welcome to part 2 of the program construction chapter. In this video we're going to look at the principal stages involved in the compilation process, such as lexical analysis, symbol table construction for A2 students only, syntax analysis, semantic analysis, code generation and optimization. And then tagged on to the end, we've got to distinguish between and give examples of translation and execution errors. Now remember, the compilation process, its job is to convert high-level languages into machine code. So if you look at this diagram, each one of those stages will take us through the compilation process to get us to that stage. What I would do, my advice to you, is to learn that diagram because it will guide you through all the steps needed to get to machine code. And again, I'll tell you which part is for AS students and which part is for A2 students. But like I said before, it's useful knowing this anyway when you make it to the second year. So here in the lexical analysis stage, it's the first stage of the compilation process, you'll see some code. What we're going to do is we're going to remove all the white space and unneeded punctuation. The remaining code is then tokenized, which means it's turned into tokens. Any error messages are produced at this stage if we run into any problems. And you'll see the code is broken down there by keywords and identifiers. Keywords are defined by the language, identifiers are defined by you. In the syntax analysis stage, what we have to do now is produce a symbol table or a dictionary. In the exam, we'll call these reserved word tables and identifier tables. That's for A2 students only. Tokens are checked to see if they fit the grammar using something called Backer's norm form or regular expressions. Again, A2 students only. And then abstract syntax trees are generated. I'll show you a diagram of what an abstract syntax tree looks like in just a second. And again, if we don't fit the grammar of the language or conform to the rules, then we produce an error message. So this is for second year students only. AS students, you can switch off for a second. We've got a question here that says, below is a segment of a source program that is to be compiled. You get some code, it asks you to construct a reserved word table and an identifier table that could be used to translate this segment of code into a stream of hex tokens. Reserved words are words that are reserved by the programming language. So you've got to just go through the code, take all the words that are going to be set by the language itself and put them in a table. So things like input, equal symbol, the multiplication symbol, plus, output, they're all the languages. They own them, not us, so we can't use them because they are reserved. The next thing I did is just assign them a random, unique hex token. Now you won't be penalised at all for any specific numbers you put in here or letters, they just have to be unique. The identifier table are all the variables that I have created myself, things like basic cost, VAT, total cost, VAT rate. There's an extra column in this one with a type because we need to define the data type of those variables. And again, I assigned it a unique hex token, and that is 5 marks in total. Now for the second year students, we're going to pause the video and have a go at this question. And then I'll put the answers on screen. You should have a couple of minutes to do this, so make sure you pause it and give it a go. Okay, answers coming up now. Make sure to be safe here. Your reserved words, your identifiers, keep them case sensitive if they are in the question. So, moving on from here, we need to talk about something called regular expressions. This is only applicable to second year students again, but it happens during the lexical analyzer. It looks for specific patterns of letters and numbers and symbols and determines if they fit our language. And these are quite good because you can build them up to allow for certain inputs. That might be things like a specific postcode, a specific layout for your number or email address, for example. You can try the link here and have a go at some regular expressions, and it will guide you through step by step of how to build regular expressions and how the rules are applied. And maybe I'll put a link in the description. But regular expressions, they can be represented as diagrams known as Automator. And this deals with the logic of computation and state machines, which is a mathematical abstraction used to design algorithms, and it can be converted directly from regular expressions. The lexical analyzer in the compilation process can make the right choice of token at any given point. So if you look at this Automator diagram, the circles represent the states and the lines between the states show the rule. So in state V1, you can go lowercase az to V2 or uppercase A to Z to V3. Now you only get to take one letter between version 1 and 2 and version 1 and 3, and then you get to version 4, which means you can have any letter reoccurring. So as long as it starts with a lowercase a to z and or starts with a uppercase a to z, then you can have any letter after that, and that makes up the rule for your variable. The bottom line shows you a print variable can only be lowercase p, r, i, n or t between the different states. And this means that it's unambiguous. Looking at semantic analysis, at this stage, it'll check that all the variables are declared and actually used. There's no point in taking a variable forward if it's not being used at all, because it's just a waste of memory. We check things like real values are not being assigned to integers to prevent truncation and things like that. We also check that the operation is legal and there's no mixed mode arithmetic. And something that's not expected is the fact that reverse Polish notation is used, but that's not covered on the A-level specification anymore. So for example, a variable equals a constant or a constant equals a variable. The first is acceptable, the second is not, because a variable can be assigned the value of a constant, but a constant can't be changed with the value of a variable, and this is what semantic analysis is trying to check. So what happens if we don't stick to the rules of a language? Well, we get a syntax error. But what is a syntax error? We get syntax errors when the tokens passed to the compiler don't match the rules stored within the compiler. Once the syntax has been checked to be 100% correct, then the compiler then can construct an abstract syntax tree. And this is what an abstract syntax tree looks like. And it looks like a binary tree structure that you might have looked at during your data structures chapter. So how do we convert this into machine code? Well, once the abstract syntax tree has been created, in the machine code generation stage, we look at each node on the tree and then we convert the elements into machine code. Now it's worth noting here that if at any stage of the compilation process there is an error, there is no point in compiling any further. The key stages at this point are 1. To convert elements of the abstract syntax tree into machine code, 2. Allocate registers to minimize memory access, and 3. Optimize the machine code to improve efficiency. Now when we say optimize machine code, what do we actually mean? Programmers over time have become very lazy and very inefficient at writing code. The higher level that you write in, the more sloppy the code becomes. Most programmers don't even know or care that their code is actually inefficient. Many compilers perform a number of optimizations for the developer, and this could be everything from the removal of code, adding in procedures and functions to make your code more efficient, or implement recursion. And you never have to think about it. So we've been through quite a few stages there. We've looked at the lexical analysis stage, syntax analysis stage, semantic analysis stage, machine code optimization stage, and one thing that I will mention is the linking process. I said before in the previous video, the fact that if you import libraries, then you need to link it to your project. If you don't do that, then you will get errors in your code because you'll be referencing things that don't exist because you've not imported your libraries properly into your final exe. And that process at the end is called the linking process. The next thing we're going to do is we're going to talk about the different errors that we could potentially get during the compilation process. The first type of error that we're going to look at is something called an execution error. An execution error, also called a runtime error, occurs when the program is running. And usually there's nothing wrong with the code, it just crashes abnormally. And there's a few different execution errors that may occur. Sometimes the division by zero or reading past the end of a file, potentially overflowing a stack, overflow of a data type, i.e. an integer being too big, or even trying to access an out-of-range array element. Comparing those to translation errors, a translation error such as a syntax error occurs when the program is being compiled. Syntax errors are mistakes in the way the code is written. Your IDE will normally pick up some of these errors, but sometimes they slip through and go through the compilation process. Translators can only execute a program if it is syntactically correct, and common syntax errors include spelling mistakes of keywords or variables and incorrect use of punctuation. We also have semantic errors as well, which is illegal variables that have been used or haven't been declared yet. And then finally, a linking error. We just talked about the linking process, but linking errors normally are created by libraries that haven't been linked to the project that you are trying to call a standard function from. And that's the end of our video today. And as always, thanks for watching.